Hello everyone, welcome to my video on the product rule. Up until this moment, we've been dealing with the derivative of functions individually. We've never had a multiplication of two functions. We had a multiplication of constants, but now we're dealing with the multiplication of two functions. So you have to catch that difference. And the product rule states that if f and g are differentiable, so both their derivatives exist, and we let k of x equal f of x times g of x, so the multiplication of two functions, this implies that the derivative is not what you would think. It's not the derivative, you don't derive each term individually, as you would if it was an addition or a subtraction sign. Here, we have to apply this formula here. So the derivative of k prime of x is equal to, you first start off by deriving the first term, so f prime of x, and then you multiply it by g of x. You completely leave it alone. You do not touch g of x, you just recopy it. Plus, so we have an addition sign. Now, the f of x you leave, you do not touch it, you just recopy it. And then you have to take the derivative of the second term, the g of x, and multiply it. And this is how we use the product rule. This notation is a bit difficult to memorize, so the way I would write it, or memorize it on a test, let's say, is if I have a multiplication f times g prime, so we're taking the derivative of two functions, then I would write it as f prime times g plus, let's stay consistent with this notation, f times g prime. Okay, so this is the notation, this is the way I would rewrite it. So this is an easier notation. Okay, so easier notation. So if you want, you can recopy this. I'm going to erase it just to give myself enough room to prove the statement here. Okay, so looking at the proof. Okay, so for the proof we have k prime of x, by definition, is the limit as h tends to 0. Usually we have an f, but now we're using k, so don't get attached to the letters. We have k of x plus h minus k of x, all this divided by h. Okay, and if k of x is equal to f of x times g of x, then k of x plus h, you're just substituting the x's here with x plus h, giving us the limit as h tends to 0 of f of x plus h times g of x plus h, and then minus k of x, which is just f of x times g of x. Okay. So in here we use a method called garbage in, garbage out. It's a fancy way of adding nothing. And this is where proofs get difficult. Whoever came up with this just tried it out and it ended up working. There's really no reason to do this, but it works. So what we're gonna do is take our limit here, whatever's written in black, I'm gonna keep it. So limit as h goes to 0, I'm gonna keep the first term, f of x plus h times g of x plus h. But what we're gonna do now, I'm gonna do it in red, is I'm gonna subtract out a term and add a term. So we're gonna subtract the term f of x plus h times g of x and then add it back in. Again, whoever came up with this, like, there's really no reason why he chose this. It ends up working. And then I'm going to end it with our f of x times g of x and divide the whole thing by h. Okay. And this is what's difficult about proofs, because sometimes you have to add, subtract things to get the job done. So that's what we're doing here. Now, if we look at the first two terms, we're going to factor out an f of x plus h. So limit as h tends to 0. I'm going to essentially split the first two terms with the last two terms, giving us f of x plus h. If we factor that out, we're left with a g of x plus h minus g of x, all that over h. Okay, so that's the first two terms. Now I'm going to take the last two terms plus, and whenever you're taking the limit, you're taking the limit of each term individually, so I could split it up. This is our properties of limits. We're allowed to do this. And the last two terms, I'm going to factor out a g of x, leaving me with f of x plus h minus f of x. And we're just going to divide the whole thing here by h. Okay. And now what we're going to do is when you have a multiplication, again, the limit, you could take the limit of each term individually. Okay, and this gives us the limit as h tends to 0 of f of x plus h times the limit as h tends to 0 of what's in the square bracket, g of x plus h minus g of x, all that divided by h, plus the limit as h tends to 0 of g of x times the limit as h tends to 0 of what's in the square bracket, f of x plus h minus f of x, all this divided by h. Okay. And what we end up getting with this, I'm just going to squeeze it here on the bottom. If you take the limit as h tends to 0 of just this first term, f of x plus h, what we get is essentially the h goes to 0. So all we're left with is f of x. So this is f of x. Next, if we look over here in the square brackets, we have the limit as h tends to 0 of g of x plus h minus g of x, all that divided by h. By definition, this is the derivative of g. So f of x times g prime of x. Then we have an addition sign, so plus. Over here, same thing, limit as h tends to 0 of g of x. There's no h in here, so it's just g of x. And then lastly here, limit as h tends to 0 of f of x plus h minus f of x divided by h is just the definition of a derivative. It's the limit definition of derivative for f. So it's f prime of x. Okay. And this is our statement. It's written in the wrong order compared to what we have here, but it's essentially the same thing. We have g of x times f prime of x, which is what we have here. The order in which you multiply doesn't matter. 2 times 3 is the same as 3 times 2. So that's okay. The fact that I ordered it, it's in the reverse order. And the fact that you're adding them, it doesn't matter what you had first. So f of x times g prime of x, f of x times g prime of x, we're okay. And you're adding them. This is the proof. Okay. So let's take a look at a couple of examples. Okay, so this is our first example over here. Find the derivative of f prime of x given that f of x is equal to x to the 5 times sine of x. Okay. So here is the rule. Keep this in mind. So if you tried this on your own, you paused the video, you tried this on your own, and you got 5 x to the 4 times cos. This is a common mistake, so be careful. This is wrong. Okay. So remember, what you have to catch here is the fact that we have a multiplication. And we have a multiplication with two functions. It's not a constant. It's not, let's say, 2 times x to the 5. Here you don't have to use product rule. If you want to use product rule, you could. It would still work. It's just, it's more time. Whenever you're multiplying by a constant, you just use the constant multiple rule. You deal with the x to the 5. Leave the constant in the front. But if you have two functions, x to the 5 times sine x, you have to recall to use your product rule, which states to take the derivative of the first term. So the x to the 5, I have to be careful in my notation. Let's call this k. This is k prime, this is k. Let's call this k of x. Okay. Just because I'm using f here, so I don't want to use f on two different meanings. So if this whole thing is k of x, let's call this piece here the x to the 5 our f, and let's call sine of x our g. Okay. So if you're looking for k prime of x, what the formula is telling us is to first take the derivative of just f. So what's the if f is x to the 5, what's the derivative of just f? So you could do this on the side if you want. That's one way of doing it. Another way of doing it is you can write x to the 5 and set yourself up prime. So x to the 5, I'm going to put it here because that's my f. I'm going to take the derivative of it times g of x, which I'm just going to leave. We know it's a plus because I'm just following my formula. For product rule, we have a plus. And then we're going to write f, we're going to leave it alone. So f, we're going to leave it as x to the 5 times, and then g of x, we're going to take its derivative. So sine of x, and then put the whole thing on prime. This is one way of doing it. You don't have to do it like this, but if in the beginning this helps, you could do it this way. And now we're ready to take the derivative of each term. So the derivative of x to the 5 using the power rule is 5x to the 4 times our sine of x, which we leave, we don't touch, plus here we're going to leave our x to the 5, and we're going to take the derivative of sine, which we saw in a recent video that the derivative of sine is cos. Okay. If it says to find the derivative, you're done. If it asks you to simplify, one extra step that you could do is find the GCF of both these terms. The most you could pull out is an x to the 4. So if we remove x to the 4, then we're left with 5 sine x plus cos x. Oh, sorry, plus x cos x. Because we removed 4 of them, we have 5, so there's 1 left. And this is the answer. So this is another example we have. Find k prime. K of x is equal to x squared times ln of x. Okay. So again, we have a multiplication of two functions. This screams out product rule. So let's go ahead and apply product rule. Another way of doing this, compared to the first example, if you want to pause the video and try it on your own, I strongly encourage you to do that. Another way that I've seen teachers show this is they'll call this f, they'll call this g, that's fine, and then they'll write it on the side. So this is just side work. They're going to write f of x on the side is equal to x squared, and then they're going to take the derivative of it on the side. So f prime of x is equal to 2x, g of x is ln of x, and the derivative of ln of x, g prime of x, we saw in an earlier video, is 1 over x. Okay? And then you just complete the rule. So this means that k prime of x is equal to f prime times g. So you have f prime here, which is 2x, times your g of x, which is just ln of x, plus f times g prime of x. So f up here is x squared, and your g prime is 1 over x. Okay. So again, you have to always simplify your answers. Well, if it says to find the derivative, this is sufficient. If it says to find the derivative and simplify, what you're going to do is go further. Here you have x squared times 1 over x, so what you get is 2x times ln of x. So x squared over x is just x, because you're essentially dividing. And what you can do now is factor out an x. Both these terms have an x. So we're left with 2 ln of x plus 1. If you want to make sure, just distribute this x back in and see if you get back what you started with. Okay. Good. So let's keep practicing. Okay, so in this example, try this on your own. Slightly more difficult, but same concept. What you have to catch is that you have a multiplication. So again, pause the video, try it on your own, see if you get the same answer as me. There's two ways of doing this, and you could have answers that look different from mine but are actually equivalent. So if you don't have the exact same answer, your answer still may be correct. But the way I'm going to do it is I'm going to treat this as f, and I'm going to treat this as g. Okay. You may have been tempted to distribute the e to the x, which also works. It takes a bit more time because you're going to have to split it up into two product rules, but your answer is still correct. So that would be fine. I think this is the faster way, the more efficient way to do it. Okay, so k prime of x is, I'm just gonna straight go into it following the rule. So the first thing is take the derivative of f to get our f prime. So the derivative of this, what we get is 3. Whenever I have a square root, I right away rewrite it as a fraction in the exponent. So 3 times x to the 1/2. So now we can use power rule here. So 3 times 1 over 2 x, and then we're going to subtract 1/2 by 1, giving us negative 1/2. Okay. That was the first term. And then over here, when you take the derivative of x to the -2, you get minus 2x to the -3. All this here is simply I'm just going to write it in red. This is just the f prime. Okay. Now we're going to multiply it by g times g, which in this case here g is just e to the x. I'm running out of room, so I'm just going to continue down here, plus, because we have a plus sign. F we leave, so I'm just going to leave this what's in brackets. 3x to the 1/2 plus x to the negative 2. And then g prime, take the derivative of e to the x. So the nice thing about e to the x is that the derivative stays the same. Okay, so this piece in the first bracket is your f prime, this is your g. Here in this bracket, this is your g prime, and this is your, this is your f, we didn't touch it, and this was our g prime. Okay, and now we're just going to simplify. Okay, giving us, first of all, let's get rid of the negative exponents, we don't want to deal with those, and this term here and this term both have e to the x, so I'm just going to factor out the e to the x. So e to the x comes out, this one and this one gone, so we're left with just here. Here we get 3 over 2x to the 1/2. Because it's negative, it drops down on the bottom. The 3 stays on top, you could think of it as 3 over 1. So the 3 is on the numerator, the 2 is on the denominator, and then x drops down to the denominator. Here we have minus 2 over x to the 3. If you're thinking of putting the 2 on the bottom, that's wrong, be careful. Each guy has its own exponent. The exponent of 2 is a 1, so it stays on top. The exponent of the x is negative 3. Since the exponent of the x is negative, that's why you drop only the x down. Okay, so that's this term here. Plus, because we have our plus here, and now the f that's left. We have 3x to the 1/2, and then here we're going to drop the x, so plus 1 over x squared. Okay, and this is the final answer. We can't add any of the terms, they're all different, so we're done.